Okay, welcome to video number 47 of the Diaries of a Coronavirologist YouTube channel. Today is the 25th of December. Merry Christmas, everyone. It's my Christmas special. Actually, it's the 23rd of December. I'm recording this 2 days early because I don't want to be sat in the lab on Christmas Day, but I was sat in the lab 2 days before time, and I'm just going to post this on Christmas. So I wanted to do a very short video to post on Christmas where I talk a little bit about science, but with a silly outcome at the end. So I often talk on the channel about infecting cells in the lab with the SARS-2 virus that causes COVID-19 and working out whether that's impacted by things like antibodies or drugs. And so I just wanted to talk a little bit about that. So we use plastic to grow cells. I've got an example here, which is a 96 well plate. So on this you can see there is a grid that I'm holding upside down that is 8 by 12. So it goes A through H, 1 through 12. So that's 96 wells. Each of those wells is plastic and cells can grow on that. And you can then infect those cells and see what impact that has with treating the virus with antibodies or something like that. However, there's also certain types of plates that have significantly more wells that you can grow cells in. So this is a 384 well plate. So there is 16 by 24 here to give 384. So we can grow cells in that dish, and we can then infect it with the virus and look to see how many cells are infected. So here right now on the screen, what you're seeing is an example of that. So these were cells that I plated in this 384 well plate. Well, not this specific one, but in a 384 well plate. And then I infected with the virus. I chemically fixed it, so everything's been fixed in place. There's nothing infectious anymore. And we've then used fluorescence to work out what cells are infected. So this is a technique known as immunofluorescence staining. And what you're looking at more specifically here is, in blue, the nuclei of cells. So the nucleus is where all of the DNA of the cell is held. So it's the same in us humans. All of our cells have nuclei that house the DNA. And it's in blue because we've stained it with a chemical called Hurst. Apologies to any German viewers, I'm sure my pronunciation's horrible of that word. But this is a chemical that binds to DNA, and then when you use fluorescence, it emits light in the blue wavelength, so we've coloured it in blue. In green, what you're seeing are cells that are infected with SARS-2. So the green is denoting the presence of the viral protein N. So SARS-2 produces a protein called N for nucleocapsid. We've used antibodies to bind up all of the N in those cells. And then we've used an antibody that binds to that first antibody, which has a chemical on the end which fluoresces in the green part of the light spectrum. So you're seeing the cells that are producing the N protein, which are the ones that are infected. All of the cells that you can see by the blue nuclei that aren't surrounded by green are the uninfected cells. So across all 384 wells of the plate, we can image those and look to see how many cells are infected. And with a very expensive piece of equipment that can image the plate and it can quantify the number of infected cells, we can work out the percentage of infection. So this example I'm using here, this is about 40%, maybe 35% infected, and we can quantify that. It's then possible, of course, to turn that into heat maps. So setting a heat map from a range of 0% to whatever the highest percentage infection was, which is around 40% for this experiment I did, we can make a heat map. And we can then overlay that heat map and the percentage infection onto a full map of the 384 wells. So what you're seeing here is technically SARS-2 virus that causes COVID-19, wishing you a Merry Christmas. I had to pipette out virus into each of those wells, and if you remember me showing you a 384 well plate at the start, those wells are pretty small. I missed 2 in the S. I'm very annoyed with myself, but overall my accuracy was pretty good. But this is SARS-2, as I say, technically wishing you a Merry Christmas. COVID-19 has obviously ruined a lot of people's Christmases, and I'm not exempt from that by any means. I wanted to be in England right now, and I'm not. I also wanted to be in England in March, but I couldn't be because of lockdowns. I'm very much missing my family and friends and my home country, as much as I love Baltimore. But because I can, I decided I was going to make SARS-2 coronavirus wish everyone a Merry Christmas, and also test out our robot staining protocol for using these 384 well plates, because it really ups our ability to do science in the lab. I'll be back to doing proper science videos in the new year. This was just a silly one to say Merry Christmas, and I hope everyone's having a great day.